4 miles is even more. 4 miles is 128 inches of drop.
Yeah, but where most people mess up at is where they go out and they're standing and they're trying to look out over the ocean. And I've seen this also myself. You take a telescope, a good one, I mean a real good one, and you go out and you pick something 250 miles away, an island or anything, or a ship, you should be able to see it. Should you not?
Right. Well, do you know how our eyes work and how vision works over distance?
I know all about that, and I look, I'm not... I've got telescopes myself. I can sit here and watch the International Space Station go by, satellites go by. We can do all this all day long.
But we don't know. Again, we can speculate that they're up in the sky, but we don't know how big they are or how far away they are. We just believe what they blindly tell us and assume that's what they are.
Well,
I'm just being honest with you.
Well,
you can use a triangle to figure out how far they are. You can use trigonometry to do that.
Yeah.
No,
it's extremely simple.
That's not true. You can't figure it out.
It 100%
But
is.
with math, you can put together a guesstimation and a hypothesis based on scale. That's all you can do. You can't verify anything with just simply writing in a formula on paper. The only way you would be able to do such with the scientific method, you would literally have to grab a tape measurer from point A to point B or some type of tool, unit of measure that could be calculated, and that's how you confirm. Otherwise, you can say anything is at any distance.
Except
now
we do have the exact measurement, and you deny it.
Here's my example. Right? So the International Space Station that we see flying in the sky, right?
Yeah.
Now, what I could do is I could take my drone and put my drone up 400 feet in the air, and I could cover up the International Space Station. Now,
you know how you can disprove that?
Hold on 1 second, please. Let me finish what I'm saying. Now, is my drone moving as fast as the International Space Station? It's not, but I could move my drone at a scaled pace that I could completely cover up that International Space Station. So if I were to make a movie and I wanted to replicate the ideal of an International Space Station, I can say my drone is the International Space Station flying by at the same exact speed as the International Space Station based on scale. Now, if I pulled that International Space Station further away from Earth and I said, you know what, I believe it's X amount of miles away, so would the speed of that item also scale to speed up as well. So all we can do is make a guesstimation and a hypothesis mathematically, but we can't verify or confirm.
Okay. Well,
Gene,
let me tell you this. I shoot for a living also. I'm a shootist. I shoot bullets. I shoot guns. I shoot.
I do too.
Okay. So
right.
you telling me that a rangefinder is not work?
I don't know how that relates. I'm sorry. You asked me a question and just laughed. How rude are you?
2000.
I know how.
Hold on. I actually have to tell you to shut up now because now you're being disrespectful. Don't ask me a question and then laugh when I start to answer you. That's a pathetic man's way of communicating.
Go ahead, answer me.
Thank you very much.
Rangefinders only work on the ground, sir. They don't work at things when you point them in the sky.
Bullshit.
No, they don't.
Kevin, let me just keep this simple. I need to fast forward this with you because you're getting combative. I thought we were going to have a cordial conversation, but now I have to just be blunt. How much does Earth curve per mile, Kevin? And why don't you know? Because that should be the first thing that you should be studying before you think you're going to have a conversation, particularly with me. Particularly with me.
With a rangefinder.
Okay, well, how much does it curve? And if it doesn't curve, then how do you have a dome and all the water?
Okay, now so I'm being respectful for you, and you're being disrespectful, so I'm being patient right now. And I'm going to ask you again before you deflect and start asking about the dome again, because this topic is if the floor curves or not. This should be the fabric of the discussion. We shouldn't be talking about the sky like astrology. This is geology right here. So again, if you don't know, be respectful and say, Gene, I don't know. But if you come back to me with some type of deflection, I'm going to know that you're not a sincere man. And I'm looking for sincere men to speak with, and women, sincere women as well. So I'll ask again, do you know how much the globe model is said to curve per mile? Yes or no?
It is said to curve 8 inches drop per mile.
Okay, so the extension of that, I have to ask you if you understand how that scales. So do you understand how much drop there should be at the surface after 10 miles?
Yes, I understand.
How
I'm
much?
not a dumbass, okay?
Okay,
But
so do you know
also-
the answer, yes or no? If you don't, that's okay, but I'm asking you, do you know? How much drop should there be after 10 miles? This is my litmus test to even have a conversation with a person, to be honest with you. So are you going
Well,
to
let me
pass
tell
it
you
today?
this. I'm not dumb enough to not think that a goddamn sun can come up and you can see it under the
So you did exactly what I said you would do.
Dumbass,
You actually deflected like I said you were going to do, but I asked if
I'm
you could
not
be a man of
deflecting
integrity.
shit.
So
I'm
this is
just
my
telling
question.
you, I can look
This
out
is
my
my
back door and tell you
question.
this
This is my
motherfucker is round, buddy.
question. You're showing me that you don't have integrity because my question is an integrity test.
All right, well, fuck you, let's buy.
All right. Do you know how much the globe curves after 10 miles? Yes or no? Right.
He doesn't, Gene. 99% of
If the surface curves, how much does it curve? Most globe believers, like you said, GlobeDenier, they don't have a single clue. They're taught, like we all were, to point at the sky.
Okay, I just want to cover my original points because somebody else talked over me and I just muted myself because I didn't care to talk over them because that's just useless. But anyways, we have the surefire measurement for how high up the ISS is. You guys just deny it. So how am I supposed to use a surefire measurement that you guys will just deny?
Canada. Look, Canada.
I'm Saint Nick.
You
This is
have
my
to
account. I was also
believe-
banned.
Right. So you are, and we are, blindly accepting what NASA
It's
tells
not blind.
us. It is, my friend,
Provides
because
it.
we can't go there and verify it. So we are taking their word for it. That's what we're trying to tell you. They're telling us it's 260 miles up or 265 miles up, right? Moving at 17,500 miles an hour. We can't verify that.
Can
We
you
don't know.
verify the bottom of the Mariana Trench is cold?
No, we can't. We can't
That
go
has nothing
there.
to do with flat
we have
Earth.
to take their word. We have to take their word for it. What I'm telling you is this: we're blindly accepting what NASA is telling us without really putting any critical thought behind it.
You can put critical thought behind it. And that thing you were talking about, guesstimations, when you're using trigonometry, it's just completely false. You can tell how far something away or how far away something is using
Canada.
trigonometry
Here's how you do that.
to the
Here's how
very
you do it.
kilometer.
You have to know, okay, the size of that object, right? And you also have to know where you are has to be stationary, because if both objects are moving,
What?
yes, hear me out. If both objects are moving, you have to have one reference frame that is not moving. Okay, and the sun is always moving above us between the tropics. Okay, which is why I said globe earthers claim to know all this stuff, all this.
Run away.
I mean, that,
Reference frame.
You just mentioned it. What do you mean?
Because
what reference frame?
triangulation would require a triangle, right?
Yes,
Okay, so how does a triangle work on a curved surface?
because you're always level with the ground, dude.
Okay, again, if the sun is above the equator and I'm in the northern hemisphere, okay, tell me how I'm going to get an angle or an elevation angle if the ground is curving.
Your initial angle, your very first measurement would be a 0 degree angle straight up where you're looking straight at the sun. You move a set amount of distance, whatever distance you want, and then you take that second angle and you compare it to the first one. You use that distance.
Yep. You realize that can work on a flat surface too, right? Because you'd have to bake in a radius to get the curvature.
Okay, so why don't you measure how far up your sun is?
Because we don't know the size of the sun, and the sun is
You
always
don't need
moving.
to.
Yes,
You don't need to. No, you
Yes,
do not.
Because I'll tell you why, Canada. Because the sun, if you also have to have somebody directly below the sun and know exactly where that sun is in the sky. But flat Earth sun is different than globe Earth sun. You guys believe that the sun is like this physical object in the sky. We don't claim that. Okay, we don't claim that at all. We know that the Atmos acts as a lens. Okay, are you following me? So that sun could
I'm
be
listening.
3,000 miles away. It could be in the firmament projecting a light into the atmosphere. We don't know. We can create hypothesis, but we don't have the exact numbers because we can't give them to you. There's no way of knowing, is what I'm telling you. We can speculate, but that wouldn't be scientific.
That's why the globe model is so much better, because we can figure out things to the exact decimal. How far away is our sun? What is it composed of?
Who is we? But think of it like this, right? This group of people have told you to believe all these things, but you can't independently verify it. You can't.
Yes, you can.
No, you can't. No, you can't.
What do you mean you can't?
If the sun and the moon both look the same angular size in the sky, and they're just magically say, oh, well, that's because the sun is 400 times further away and 400 times bigger. That's why they both look the same size.
The same angular. That's not even remotely what I'm talking about right now.
No,
I'm talking about how we can calculate the distance.
Yes, and how they're telling you they calculated the distance, okay, is completely ridiculous.
Can I just ask Canada something?
Yeah, what's up, man?
Have you measured the distance personally yourself?
Yeah, you do it in science class in grade 10 in Canada.
I don't. Gone and measured it.
Yeah, you do it in science class in grade 10.
So you took a tape measure to it.
You're not getting what I'm saying. You have not gone yourself and measured this shit, have you?
What we're telling you is this: when you guys use that math, you're using it off of globe Earth math. You're not using it off of reality.
That doesn't exist, man.
It does. It does.
You can triangulate anything on this planet that you can physically measure with a tape measure, and it will work.
You know how triangulation works?
Of the time.
Do you know how triangulation works?
Yeah.
It's with 3 points, correct?
Yeah.
Okay, so think about that. How does triangulation work on a curved surface?
Do you know?
It doesn't.
You know how it's 3 points, right?
Yes.
But do you know that you can take 2 points to figure out the third point?
Yes, I do know.
Yeah, we have two of those points on planet Earth to figure out the last point, which is whatever we're trying to figure out the distance to.
It doesn't work on a curved surface, my friend.
What are you talking about? It doesn't work on a curved surface. Oh my lord.
It has to be a level plane.
This is the problem.
You are level on the planet.
Level is not curving.
Yes, you're right.
Level does not mean flat.
You're right. We are on a level plane.
Yeah, level does not mean flat. You are on a level plane.
Level does mean flat.
Stop.
Level does
No,
mean
it doesn't.
Flat. Yes, it
Level
does.
is not flat. Nope.
Level, listen to me.
Nope.
Level
Yes,
is
means flat.
synonymous with flat, but flat does not mean level, but they certainly don't mean curved. That's what I'm getting at.
You guys are gish galloping, and then you can't triangulate something and know for a fact, and that's what you're claiming. You're wrong. You can triangulate something and you can make a hypothesis, but it's geometry. It's just geometry, and I told you it's scalable. So if you have you need at least 2 legs and some basic algebra, right? 1 plus blank equals 3. Well, what goes in that spot? Right? It's 2.
Yeah.
So, of course, if you're doing geometry, you need 2 verified legs, right? So, what did you verify from the planet Earth? You can't verify anything. It's just a guesstimation based on an assumption. It's based on an assumption.
What are you talking about?
The figures
Take the angle of you staring at the sun. It'd be 0. Now walk. Okay, walk any given distance you want.
And do you not understand? Again, the sun is moving. Number one, right? So you're already talking about a moving object. And again, if I were in a car and I
we're moving with it.
If I were in a car hunting a deer, right? I have a lot of math to figure out now, right? So it's not as simple as you're making it sound, because you're making it sound as if I guess we're stationary, right? So this is where it gets complex, and you're not even looking at it. You're just trying to win the argument, but you now have to put together math that's not only triangulation, but it's actually moving triangulation, right? That's just two-way crazy complex, man. That doesn't work that way. And again,
your word salad is incredible.
No, I don't have a single bit of word salad.
Moving triangulation.
Okay,
really?
bro, you're the one that is claiming you can exactly tell where something is, and again, like GlobeDenier said, no, you can't. Okay, how about this? If I had a red dot, right, in the sky, would you be able to just look at it and tell me, I know exactly how far that is? No, you wouldn't. You know why? Because number one, you would have to know how big that red dot is first before you could even start scaling it down, right? So if I had a balloon, right? Or even if you looked at it in the form of like a silhouette, right? How would you tell how far a silhouette is? You couldn't tell. You can't tell. It's just an apparent location. So what you're going to do, you're going to have to try to come up with a guesstimation to make that math work. That's the only thing that you can possibly do when you're looking at something and you don't know what it is at all. You would have to know, okay, well, that's a Volkswagen Bug 1972, right? So I know that that's about 10 feet long. Now, I'm going to put that in scale together about 10 feet. So that thing, if I can see about this much in my scope, that means it's approximately about this far away. Then you're putting together calculations. But nobody knows how big the sun is. No one's verified the moon size. No one has. So this scale, like I keep saying, in scale, again, I can make a fake movie and scale down the moon, the stars, a spaceship, Godzilla, King Kong, and make you think that there's a big monkey on top of a Empire State Building. It's just scale. It doesn't verify. And you guys don't understand the difference between like a postulation and like estimation and then actually verifying things with the scientific method. It needs to be repeatable, duplicatable, demonstratable, testable, and repeatable. And we can't test the size of the sun. We can't test the size of the moon. We can't do it. So we have science priests that tell us this is what it is, and we're going to wave our magic wand and read our scripture books of scientism and tell you what it is, and you're going to believe it, just like it's another religious cult that you're following. But you can't verify that. And so this is where I say, stop looking at the sky to try to verify that what you can't verify, and let's disassemble the globe together. Why don't you think a little backwards and flip-flop it a little bit? Instead of trying to defend the globe, disassemble it. How much curve per mile? There should be 8 inches per mile squared. We can see too far. And I have an example up on my screen.
Parabolic
Hey, Dev, you're a mechanical engineer, right?
And somebody just said it's a parabolic approximation. They need a math lesson. Who needs the math lesson?
Dev, can I just ask a question real quick?
Dev, you need a math lesson?
Okay, can I just ask something?
Of math.
Yeah, Dev, you're a mechanical engineer, right?
Currently, I'm studying. I'm getting a graduate degree in mechanical engineering.
Okay, perfect. I'm like by no means a mechanical engineer. Can you please explain that why everything he just said was complete word salad? Because I know you can better than I can.
I just joined because I was walking outside, so I didn't hear most of what he said. But I did hear the part about 8 inches per mile squared. The problem with that is a parabolic approximation, and over short distances, it is kind of accurate, but it falls off very quickly because.
Are you a math expert? I have to ask. Are you a math expert?
No, but I've taken many math classes.
Okay, so let's talk about this for a minute. Hold on, because you're talking down to someone that has spent hours and hours and hours trying to disassemble the globe. So before you continue sharing misinformation, I understand and I can hear how new you are to this conversation. So I'm going to be patient with you and be respectful. So just so you know, the math that gives us 8 inches per mile squared is simply geometry. You can use arc length, horizontal length, peak to peak. You can use 8 inches per mile squared in contrast. You can use chord length as well. Now, the challenge that I had when somebody told me it was 8 inches per mile squared, I was brainwashed by Professor Dave. Professor Dave told me that you can't use parabolic equations to measure curves, and you don't know what 8 inches per mile squared is. So I said, you know what, whenever I hear that term, you're a big dummy, until I started to learn the math. Then I realized any parabolic equation that I use, it's appropriate, because that's what we use to measure circles, curves, and curved planes. We use parabolic equations. Oh, so much so that what you just said, I have to disassemble it. You said it's only usable up to a certain distance. Well, what is that distance? I know you don't know, because this is the script that they tell us, that it's only usable up to a certain distance. When in all actuality, if we use chord length is 100% accurate and is not an approximation if we're contrasting that math. So when we do contrast it with something that is an approximation, like the very accurate chord length, we realize that how accurate they really are. And so when we apply 8 inches per mile squared, we're just deriving that from the circumference, which is 24,901 miles, based on the radius, which puts us at 3,959 miles. No matter what you say, no matter what you do, no matter how you squirm and try to fight about it, 1 + 1 = 2 at a 3,959 mile radius has an approximate drop of 8 inches per mile squared, not 7 inches per mile squared, not 9 inches per mile squared. That's not up for an argument. So what I think you should do is just take a little deeper look, maybe touch an Earth's curvature calculator for the first time, because we wouldn't have this conversation if you had touched one, and you'd realize that that is the proper math that we use. Even land surveyors make the assumption. So don't watch Professor Dave anymore. There's only 1% error at 1,388 miles, and no one's making a single observation that far. So what that stresses is how accurate it is for all observable distances.
I mean, you can say all of that. I mean, at the end of the day, it's a parabolic approximation. It doesn't matter what you think of it or how you feel.
How about this? I agree with you. Now what? What does that mean? Are you trying to say it's wrong?
It is. That's not the equation of
Oh, I'm
curvature.
sorry. So now I see, I'm digging a little bit. You think because it's a parabolic equation, it's wrong. What would make you think that? Could you provide some evidence that supports?
I didn't say it's an equation. I said it's a parabolic approximation.
Okay. So it's a parabolic approximation that's very, very accurate, and land surveyors make it as an assumption. NASA agrees. So what are you saying? Why are you discrediting the globe math? Because we agree there is no 8 inch per mile squared curve. I'm just trying to figure out if you understand that you're actually just going against the globe model by agreeing with such.
NASA
Let's be honest. Let's be honest. You haven't used an Earth's curvature calculator, right? And if so, which one have you used?
I have not used the Earth curvature calculator.
Okay, so respectfully, my friend, respectfully, my friend, start there. I'm calling out your shots like my own teenagers, right? I know your steps before you even say them. You even brought up the things that I'm calling out that I tell you 99% of people say this because it's scripted for you to reply with these same things. So I'm asking you respectfully, don't you think I would be challenging you to do such if I can hear that you're not experienced with these numbers? So if you now then grab an Earth's curvature calculator and you can maybe grab 5, maybe 6 of them to contrast, because it would be very biased of you to only use one. So I say use 6 of them and contrast the difference of how much drop there should be after 60 miles. And I guarantee you they're all going to calculate 2,400 feet of drop. Why? Because standard, based off of the radius that we're given, 3,959 miles, that necessitates how much drop there needs to be after 60 miles. This is just math. This is just geometry. And again, this is an approximation. Yes, it is parabolic, but that doesn't discredit it for what it is. We use parabolic equations to approximate curves, circles, and curved planes, sections of them. The furthest we can use a parabolic equation in any type of formula based on simple parabolic equations, like we don't measure any further than the diameter. We're not measuring a quarter, you know what I mean? So we're only trying to imply this over observable distances. So for observable distances, 8 inches per mile squared is accurate math, and it is standard. I know it confused you with those videos. They are very confusing, but don't watch Professor Dave anymore.
Hey, Gene, I'd also love to give a shout out to Walter Bislin. I think he's a closet flat earther because he did design a working flat earth pad model, and he created a earth curvature calculator that we can use that still produces no earth curvature in reality.
Yep. Shout out to Walter.
Meaning it only shows up on a computer screen and pen and paper, piece of paper. It doesn't show up in reality. So appreciate it, Walter.
Thanks, Walter.
What do you have on your screen there, Gene? Can you tell them what's on your screen?
Yeah, what I have on my screen here, this is an observation made by a doctor from the UK. His name is Dr. John D. If you want to look up a little bit more information about him, you can look up his YouTube channel. It's just simply Dr. John D, PhD. He is a PhD in spectroscopy. So he studies the behavior of light, refraction, lasers, and such. And, as an educated man himself, he was pondering, obviously the shape of the Earth, and he went into a very deep, detailed, study to contrast it. And I think he did a great job on his YouTube channel presenting it. Don't believe me? Go check it out yourself. But what he has here is from a 3.5-foot observer height. He has the first turbine at 8.2 miles away, should be approximately 30 feet under the horizon, and the last one there is 11.2 miles away, should be approximately 54 feet under the horizon. So this is just a blatant observation, that consumer technology has surpassed the globe model, and we could just simply see too far. You could actually see a boat in the horizon, and what the globe model necessitates is that the globe horizon should actually be only 2.29 miles away from a 3.5 foot observer height. So this clearly, again, is just the display that there is no curve.
Hey, Canada and Dev, you guys know who Roseanne Barr is? Does that name ring a bell?
No.
So Roseanne Barr had her own TV show back in the 1980s called The Roseanne Show, and she had another show, and she does stand-up comedy, and she's pretty like well known among people over 40 years of age. Wouldn't you agree with me, Gene?
Yeah, I'd agree.
So she has a podcast that she does, and it's on Rumble, and it averages about 1.5 to 2.2 million views each week. And she had Flat Earth David Weiss on her podcast not more than 10 days ago. And it's already got over 10 million views. And then there was another important podcast, I think, that had David Weiss on there. Oh, yeah, it was InfoWars, where for the long time Alex Jones was against the Flat Earth stuff. And then he had David Weiss on. But David Weiss has been traveling around doing podcasts all over the country. Okay, so this is something not to discredit. There's people waking up. I mean, there's Candace Owens. I'm sure you guys know who Candace Owens is, right?
Globe, can I just ask a question real quick? Yeah, I know who Dave is. Or
yeah, Candace Owens just came out, and David
Weiss is the maybe like 60-ish year old dude with that always wears that beanie, right? Am I not mistaken?
I don't think he wears a beanie.
Yeah,
here, I'll just search up a picture of him real quick.
Yeah, you're right. You're right.
I don't know. I don't know if he wears a beanie. I know sometimes he wears a hat, but Candace Owens just recently came out on her podcast saying that someone asked her to look into flat Earth, and she has been, and because she's already denounced that the moon landing never happened, and she's probably within a week or two away of saying, guess what, the Earth is flat. So, like I said, guys, this thing is spreading like wildfire. We're not here to deceive you or pull your leg. We're just trying to tell you, go look into this stuff. There's a lot of evidence to support it.
So my question would be, why is it, do you not see the I guess, not the irony, but don't you find it interesting how the people that believe the Earth is flat that you're bringing up don't have any sort of scientific background? Candace Owens doesn't have a scientific background. Neither does David Weiss.
Dev, so let me explain. So the scientific community was basically in charge of educating the population through the Department of Education. Would you agree with me? Yeah.
Yes and no, because there's private institutions that can teach whatever they want.
Well, right.
And they teach the same thing.
For the most part, Americans got public educations through grade school and university, and I would say 98% of the
university isn't public.
No, there are public universities, sir. I went to one, but I had to pay for it. But what I'm telling you is the Department of Education and the FCC, the Federal Communications Commission, they approve everything that goes on the TV and in textbook. Okay. So if you want to indoctrinate a society or brainwash a society, you would start when people are 5 years old, and then you would continue to do so as long as they are in that education system. There have been scientists that have come out against the globe model throughout history. There's been numbers of them. Like for the last several hundred years, they've written books about it. They've done experiments disproving the globe, but they just don't get the mainstream media highlights like these other scientists do. And this is fact. Like there was recently a geophysicist in Brazil that came out, or it was Brazil or Ecuador. He came out and said, hey, guess what? I no longer believe in the globe. I'm a flat earther. And his video has tens of thousands of views.
Mm-hmm. And I didn't want to cut you off, but I just wanted to mention something. David Weiss, and I was thinking of the right person, by the way. I don't understand why in any sense of reality you'd be using him as like, what's the word? Like when you have somebody as your like, I can't.
Like a representative?
Why would you be using... Yeah, why would you ever be using him? In every single debate he's been in, he uses words and then completely misses the actual meaning of the word just to throw out term after term after term at people to make them confused.
I don't think.
Look at Dave.
I think,
I know Gene has a problem with him, but I didn't really hear why he does. Watch David Weiss's and Dave Farina's debate.
Right. So you're going back to Dave Farina, the guy that overtalks everybody and says word salad because he doesn't understand.
He doesn't say word salad.
No,
in fact,
yes,
he makes multiple
Yes,
videos explaining why everything Dave Farina made no sense. Dave Farina used terms that didn't even fit in an argument for no reason to explain something Dave Farina just said.
So Dave Farina isn't even a scientist or a professor. He's a dropout. Okay, he's a
professor.
He's not a professor, sir. He named himself a professor, and he has like 6 credit hours at a university. Okay, he's not even a real professor. He named himself Professor Dave. He has no accreditation to even getting a degree in anything.
How do you know?
Because he admitted it on one of his podcasts.
When?
This is like within a couple years. He said, I went to university, but I took a couple classes in chemistry and yada, yada, yada. I started this podcast, and now what people do, now what happens is people of authority give him talking points to talk about on his podcast. He's a nobody.
I could send you a video that breaks that down if you'd really like. Yeah, he's just a fake professor. He's just a YouTuber, and he hires writers to write his scripts for him. But he's not. Yeah.
How do you have a script when you're doing debates? How can you?
That's why he failed miserably when he debated Austin Whitsitt and got his ass
degree
to him.
Yeah.
Okay.
One second, guys. Boy, howdy. Can you please tell me your? Boy, howdy, please.
Pardon?
I need to know your age, please.
I am going to turn 54 this month.
Awesome. And
happy birthday.
Motocross, what is your age? 21? All right, thank you. And Boy and Motor, are you guys Globe or Flat Earth?
Globe. Absolutely Globe.
Okay, so back to the conversation. So David Weiss has had many times on different podcasts around the country. If you give him an opportunity to state his claim without interruption, like Dave Farina does, he makes a lot of good points. He also has an app. He also has an app called the Flat Earth Clock and Zodiac app, which have, I believe, over several million people have downloaded this app. And it's not just his content. It's people giving him content to put on the app.
Hello, can I respond, please?
Of course.
Okay. If you actually look where Dave Farina interjected and why he interjected, and just print out like the script of what David Weiss was saying, read what he was saying verbatim. The terms he was using in those sentences make 0 sense in how he uses them. 0.
Maybe
this is explained in detail. No, I mean, you can search up the definitions of the terms he's using, and they don't fit whatsoever with what he's trying to argue. That's my point.
I mean, maybe he didn't understand them, but Professor Dave, again, he hires writers, and then his tactic with debate is just mockery. 100% of the time. He even, when he just recently debated Whitsitt, who is one of the most intelligent speaking and informed flat earth, I would like to call him a teacher that there is, but even Professor Dave, he had salad dressing, props, you know what I mean? He went to just go into the debate with full mockery. Even one of the people that I like to follow, he goes by I Can Science That. I learned about globe math watching a glober break down the math in 5 different formulas. Even this glober said that Professor Dave did a horrible job. It was ad hoc, and he was just reaching for things just to pretty much say, Whitsitt, you're stupid. You're a big dummy, Whitsitt, you're stupid. You know, he really isn't that scientific of a person. He's just mockery. And honestly, I can see why people get sold on him, because he has this kind of like this charming East Coast, like, you know, smiley bartender type of like tchotchke kind of attitude. You know what I mean? Like, but he's a liar.
You know the doctor that supposedly made the photo that's in your background right now that you're like screen sharing?
I understand.
You know how go ahead.
You know how
you said he studied microscopy, right?
I didn't say microscopy. I said spectroscopy.
Spectroscopy, that's what I meant. Did you know David Weiss says you can only do it in a container?
You can only do spectroscopy in its container?
In a container. Yeah. That's the type of diluted things I was talking about that he was saying.
Well, define spectroscopy. What's spectroscopy to you? Why is
it's the study of light.
Right? Yeah. But how does it behave through what? A prism, correct?
What do you mean through a prism? You're studying the wavelengths of light.
Well, what we're ultimately saying is we're breaking down the wavelengths of light through a prism. So it does need to be enclosed. He is correct, but he says that it does need to be enclosed.
It is not. No, it doesn't have to be enclosed whatsoever.
You don't just look at the sky and then say, well, this is a matter of fact because I look at the sky. No, it's calculated. It actually goes through a device. It goes through a prism in order to be able to say that the light coming through this optic, which is breaking down, they break down the light, it scatters into the spectrum. And then they tried to say because there's this much red, this much yellow, this much blue, that we can start claiming what the material, its metallosity, how old it is. Do you understand that those are some of the things that they say they can do with spectroscopy? They can tell the metallosity of something. They can tell the way something smells. You know what I mean?
It's crazy, bro. Like that's absurdity.
Yeah. So
if you know what something's made of, you know how it smells.
And so
certain chemicals produce distinct smells.
And so Dr. John D is yeah, okay. I mean, I'm sure you want to believe that, and Uranus smells like farts too, right? That's what they tell us. It's mockery, bro. Your anus smells like sulfur, bro. That smells like farts.
That's the planet Uranus, not Uranus.
Nobody's ever said that about Uranus. And
no, they do.
That is very true. They have.
NASA
sent a probe into Uranus, and they found it smelled like sulfur.
So there is a probe in there? And I may be completely wrong.
That's the joking claim. Yes, it's a mockery joke, bro. I respectfully, I know it's hard to let go of the globe. I know it's hard. And
something has a large amount of sulfur, of course it would smell that way. That's what sulfur smells like.
The first thing a person would have to admit is I was mistaken. But no, nothing has ever left our low Earth orbit, if you will, especially to go to another planet. To think about the mathematical accuracy you would need to take to shoot something that's in free fall, millions of miles away, right? Millions of miles away, and do it on the first shot. You guys, come on, we can't hit a target long range 4 miles without 69 of them, right? So how are we going to do that with an entire full blown
talking about
a rocket ship, you guys? So we sent a probe and just hit the money shot millions of miles away, and then now that we're
we figured out exactly how to hit the money shot.
Now that we're in this what we call a planet's environment, we're going to now send back information that the computer robot up there said, oh, it smells like sulfur up here. Come on, you guys. That's not real. That's like
because it found sulfur. It didn't go.
Yeah.
It smells like sulfur. It found sulfur.
That's not real. That's not real. That's not reality.
Okay. Anyways,
not with real.
Can I just say what you just said and why it's dumb just for a second? You do believe missiles exist, right?
Of course.
Like rockets in general with computing systems that can target something.
I'm glad you brought that up, but go ahead.
Do you think they can miss?
Huh?
Or do you think they will always hit what they're aimed at?
It depends on how far away it is.
No, it doesn't. What are you talking about?
It does. Rockets can misfire all the time.
I'm not talking about a misfire. I'm talking about the computing system it uses.
It depends. Well, if the new
depends
technology,
on what
the new technology rockets, they're pretty accurate. The stuff they use, back 50 years ago wasn't that accurate.
Such as?
Well, I'm telling you, like rockets out of like a launch, like one of those things you see that travel like a truck you see traveling down the side of the road with those missiles in the back of the truck. Those just shoot in a general direction. They'll land in a general direction. They don't have.
Yeah, I'm talking about a guidance system that can actively steer and bring it towards a.
Correct. A guidance system is different. Yes.
Yeah, think of the same way we got that rover onto Uranus as the same way a guidance system works. It's a computer that does thousands of mathematical equations before it ever even leaves the ground.
Yep. Okay. So Canada,
to ensure it lands on the very square inch you aimed it at.
Yep. So I'm gonna walk you through this here. First of all, I want to get a shout out to Sacred in the chat. He's part of Flat Earth Fridays on X, and he is a great debater, has a lot of knowledge. But let's just talk about that trip to Uranus real quick, okay? Do you know how far Uranus is from Earth?
I'm guessing multiple million miles away.
Yeah, it's like 200 million miles away, allegedly. Okay. Did you also know that coincidentally all the planets fit perfectly in between the Earth and our moon? Coincidentally, if you line them up, stack them side by side. Did you know that?
That's not
I don't see the point you're trying to make.
It's okay. So here's what I'm trying to make. Do you know what the third law of motion is?
Offhand, no, I don't.
Okay, so the Newton's third law of motion is with every action requires an equal and opposite action. So let me break that down for you. So when you're driving your car down the road, the tires are turning on the pavement, right? Creating
I understand
momentum.
the law that you just mentioned.
Okay.
I just couldn't remember which one was the third law.
Right. So let's put that into another perspective. A boat, you need wind to move it, or a sail, or you need a propeller pushing the water out the back. Same thing with an airline or an airplane. You need air pulling in and pushing out, causing thrust. Okay. So if this void of nothingness or space, how exactly is it pushing off of nothing to get to Uranus, 200 million miles away?
It isn't pushing off of nothing.
It is.
What are you saying?
There has to be.
He's saying that rockets push off nothing in the void of space.
It violates the law of motion, sir. Okay. That's what I'm telling you.
That's a good point. And here's my explanation. So, would you agree or disagree that space is frictionless?
There's nothing there, so yes, it's frictionless.
Correct. So, what is the reason for a car or for if you roll a ball on the ground on Earth and it slows down? Why is that?
Well, over time, it's going to lose its momentum because of its density.
No, so there's friction on the ground that goes the opposite way of where the ball is rolling. So eventually, it'll equal out. The ball will stop. Right? When you have no friction, whatever you throw will never stop. So in the case of these probes like Voyager, for example, once you are able to leave Earth, you do no longer need to propel yourself because unless you have to readjust, right? But if you're going in a direction, you will go in that direction basically forever until another force acts upon you. That's the third law that's Newton's third law. Or no, that's first law.
What I'm telling you is this, Dev, okay? In reality, down here on Earth, there has to be something for the rocket to push off of. I understand what you just said, but that is like Narnia, my friend. It is Narnia. What I'm telling you is that math only exists on paper. In reality, space is not real. Nobody has ever been to space.
So you just completely disregarded his actual explanation of what you just asked?
I knew.
By saying space isn't real?
Are you asking how rockets work?
Bro, I knew what you were going to say before you even said it because I've already looked into all this nonsense.
Are you asking how rockets work?
No, I know how rockets work. Do you know how rockets work?
So then what do you mean they push off nothing? What are you referring to?
What I'm telling you is this, okay? In our atmos, you have different pressure gradients of atmosphere, right? Yes? Okay,
there's different layers of the atmosphere.
Yep.
Is that what you're saying? Yeah.
Yep. So that rocket, when you guys see a rocket go up, right? From NASA, does it leave a trail of smoke behind it?
Yeah.
Yeah, it's pushing off of the air. Okay. It's pushing out thrust and it's pushing off of the atmos. Yeah, that is how rockets work.
You're wrong.
You have to have something for it to push off of.
You are incorrect.
Oh, really? So how does it just magically go then?
Well, actually, I'm glad that you brought up Newton's third law because that is how it works. A great example would be if you were sitting in like a chair with wheels on it and you had a bowling ball and you chucked that bowling ball away from yourself, you're going to go the other direction from that ball. And it has nothing to do with pushing off the air. It has to do with expelling mass away from you. The equal opposite reaction of throwing that mass away from you, you're pushing on the ball is pushing you back. That's how rockets work.
No, bro, I'm not going anywhere. Bro, when I throw a ball, I don't move. I move.
Are you serious?
When your feet are on
my arm goes forward, but I don't go backwards, sir.
If your feet are on the ground, sure. That's why I said if you were like on a rolling chair that had good wheels on it, you throw a bowling ball away from you, you are going to move the other direction of the ball.
Right, but you do. The same thing is true,
and I don't want to use any violating words, so I'll just mention the Second Amendment and something with two barrels. If you've ever used one of those, the force that it pushes against your shoulder is not pushing off of the air. It's the explosion. It is the expelling of the mass.
I get what you're saying, boy. I really, really do, okay? But the imagination that you guys have to believe that a probe went 200 million miles, okay?
Can you get back to the third law of motion? Can you at least admit that the third law of motion supports rockets in a vacuum?
It doesn't, though. It doesn't, though, sir.
You have to have creates because an equal and opposite force on you.
No, bro. It does. Boy, listen to what I'm telling you.
That's the third law of motion.
Boy, howdy. Stop. There is no solid object in space for it to push off of. It's pushing off of my shoulder. Okay, that is a solid.
Pushing
object.
Off of the mass, it's expelling.
Yeah.
No, that's not how it works.
The force of the shell coming out of the barrel is equal to the force being pushed against your shoulder.
Bro, you don't get it, man. You cannot push off.
You don't get it.
That no. If I jump in the air, I can't double jump to the next phase. I'm not Super Mario.
Because you can't create a chemical reaction in your body to propel you up again.
Correct, but again,
you're not.
So again, you guys, the bullshit that you believe because NASA said so. That is appealing to authority.
I didn't realize NASA invented the first flintlock.
Oh, that's awesome. So anyway, think about what you're saying. You have to have enough fuel to propel 200 million miles. Do you understand how ridiculous that is?
Can you focus for a sec? If you have ever used one of these tools with two barrels and felt that force on your shoulder, that force that you are feeling is directly proportional to the force that is expelling the lead out the other end. That is, in fact, the third law of motion. Do you agree? Or do you think it's something else?
No, I agree. With every
that is
action
how a rocket works.
comes an equal and opposite action. I understand that, but I understand that, boy.
I'm almost done, man. If you were to use one of those double-barrel devices in the vacuum of space without any friction, you and the mass expelled the other direction would be pushed away from each other. You can propel yourself by using one of these devices in space. That's the third law of motion.
But we can't go to space and test it, boy. So therefore, it's pseudoscience.
Okay, I hear you, but what I need you to do is focus on the idea of the third law of motion. Before you start talking about how rockets need to push off of something, they don't. You understand that, right?
Rockets don't need to push off anything?
It's the same way a double barrel works.
Rockets don't propel by pushing off the ground or the air. That's not how rockets work.
No, rockets work by
which
pushing.
Doesn't require them to push off of anything. Bro, they expel mass.
I want to bring Sacred up here so bad and just let him destroy you guys right now because what you're saying is absolutely.
How we come past this?
Hey, Brooke, can you bring up Sacred? Are you listening?
Yeah, I'm listening.
Can you bring Sacred up here? This is absolute nonsense.
Yeah, I can't believe what I'm listening to. But
like,
do you know what recoil is?
You guys believe in Narnia?
Hold on, what is his account? What is it?
It's Sacred. He's down there in the chat.
Globe, do you know what recoil is?
I do know what recoil is, but you're saying things that only can be replicated here on Earth. You can't test those things in space.
Because you're denying that space exists and you're denying we've ever been there. So how are we supposed to give you our measurements of when we were in space if you just deny its existence completely?
Again, you can't test it, sir. You're blindly believing what someone else told you.
I've shot a GUN before.
That's appealing to authority fallacy. That's what you don't understand.
The third law of motion is very easily demonstratable.
You can't test it. If you can't put it through the scientific method, it is pseudoscience.
You can.
That's where I'm trying to get at.
You're basically.
But you can.
The big thing here is that he agrees with the third law of science or whatever, but he's saying you can't prove that third law of science once you get into space.
You can't.
You can. Why?
No, you
We
can't.
can.
You
I
can't
agree with that.
because it's pseudoscience.
Guys,
that's not an answer.
before we go forward,
It's because you're denying space. Dude, that's all it is.
You can't go to space and prove it exists, Canada.
before we go forward, Sacred, I want to apologize to you. I think I muted you because I saw like a comment that was wrong and I thought it was something. So, all right, go ahead. I just wanted to say that.
Sacred, can you tell these guys how they're so illogical and how a rocket cannot work in space?
Listen, man, like all we looking for, guys, is something that's demonstrable, right? So if y'all have a claim that rockets could propel in a vacuum,
That's not how they work.
then you
Rockets
should.
don't propel.
Rockets don't. Wait, there's no propulsion on a rocket. there's no propulsion on a rocket now. This is why it'd be so hard for them to talk to y'all, because it's like y'all don't even understand simple concepts. All we're looking for is some type of propulsion in a vacuum demonstrated, so that way we can have a conversation about it. And we want to try to simulate space as much as possible. We know we're not going to be able to do it in the way that you guys say that it works in totality. However, we should be able to see some type of propulsion without creating a medium and without the propellant interacting with any surfaces. So if you could demonstrate that, then we can have a discussion about it. But if you can't demonstrate that, y'all should acknowledge.
Perfect. Can I just demonstrate it for you real quick?
Say it again.
Can I just demonstrate it for you real quick?
Yeah, if you got something that you could show, turn your camera on.
He can't. His camera won't.
Just let me throw my phone into space real quick for you, because you deny that NASA's ever been to space, so we can't use any of our demonstrations.
They admit they've never been.
Wait. So
no, they haven't.
Yes, they have.
So we're trying to substantiate space, and you want to reference space to substantiate the very thing in question. That, by definition, is logically fallacious. You're literally begging the question. You're saying, hey, I know we want to prove this, and I want to use the thing that we're trying to prove as evidence. Like, no, bro, you have to reproduce it.
If you're denying that space exists, we're never going to be common ground.
That's literally logically bankrupt.
The fundamental point that I think that I would like to make is that the third law of motion does not require you to propel off of something. If you create a force in one direction, you will create a force in the opposite direction. That is what the third law states. We know that this is true. If it is not going to work in a vacuum, you'd better have a good reason why that doesn't work in a vacuum.
Yeah, it's all about pressure mediation, right? So we can interpret the calculations as such, but we're trying to apply it to actual reality.
Sacred, define pressure mediation.
Define pressure mediation? It's the equilibrium.
Define what you
pressure.
just used.
It's the equilibrium of pressure, right? The exchange of pressure. Everything's trying to seek equilibrium. Everything in our observable reality. So when we're not talking about pressure mediation,
you're referring to entropy?
Yeah, that's one form of it. Everything is seeking equilibrium. Everything. So that's what I mean by that in simple terms. But yeah, we're just trying to apply what they're saying is happening to real life. And I think that the first step to science is being able to demonstrate it. Then we can debate it. But I think that you would agree that if you can't even demonstrate what they're saying is happening every single day, every single night, shouldn't that be a red flag to you?
Actually, I have a good example. Let's say you're in a pool, right? You would agree that the closest we could probably get to a zero-G environment, besides being in a plane and falling, would be in a pool.
But okay.
You're talking about zero-G right now, but I hear you.
Yeah. So if you are in a pool, right, and let's say you have a bowling ball, right, like what you said before, and you hold it and you throw it. Let's say like you throw it in the opposite direction. Your body's not going to go backwards.
So you
throw it ahead of you. You're not going to go back.
So are you referencing an observation that's taking place within a medium?
But you're not answering the question.
No, I'm trying to get clarity. Are you referencing an observation that takes place within a medium? Yes or no?
Yeah, that's the closest we're going to get unless you want to go to space.
In space, there's no medium, brother. This is why I said gravity is not important. The medium is important. You have to actually understand what we're talking about. It doesn't matter whether it's zero-G or not.
What are you talking about medium?
Listen. We're not talking about whether there's zero-G or not. That is irrelevant. What we are trying to demonstrate is propulsion in a vacuum. So a medium is directly responsible for propulsion in your example, but there's no medium in space, so it's non-analogous. So let's not focus on whether there's gravity or not. Let's focus on whether there's a medium or not, and don't provide an example that incorporates a medium if y'all don't believe space has a medium. Let's start there.
So let me ask you something then, right? So you agree that rockets, they go up, right? Because they're in Earth's atmosphere and they get to space, right? You agree, or you disagree with that entirely?
Not the second part. I do agree that rockets do go up. We can't observe going to a rocket launch and seeing rockets go up within our environment. Yeah.
Okay. So let's say, hypothetically speaking, they get to space, right? That's what they are. They get to space, right? So you think that rockets, let's say it's going to Neptune, right? For example, you think that rocket needs to constantly propel itself through space to go to Neptune? Is that what you think?
No, it shouldn't happen. However, there are forces still acting upon it. So depending on what happens to the actual spacecraft, it may or may not. Right? You do agree, like there's other gravitational forces acting upon that spacecraft traveling all the way to Neptune. You do agree with that, right?
Correct.
So if there are other gravitational forces, it would knock it off its course, correct?
Correct, but that's
so then it would need to constantly propel itself, right?
Just that cramp. Tastes great.
No, it need to make minor adjustments.
So you just said yes. So why are you questioning if you can come to your own conclusion?
Not constant propulsion. Bro, it's going in that way.